Good afternoon, guys. In some of the homework I've set for you, one of the questions, we haven't covered all of the concepts in class. So in this video, we're going to look at how we would do question 3 from chapter 11F.1. Now going over, question 3 is consider the line with equation y equals negative 2 over 3x plus 4. In it wants you to find the gradient and the y-intercept. Now we've done this stuff, but over in part B, where it's asking you whether certain points lie on the particular line, we haven't done this. So I'm going to explain how to do A, B, and C in this section, so to complete all of question 3. Now, I'm not going to take your opportunity away of trying this question, so down here I've put together a similar question that we're going to work from. So in this equation, we'll go y equals 3 over 2x plus 6, and we want to find the gradient and the y-intercept. Now, from today's subject matter, we know that the gradient, or from learning intention 2, we know the gradient is of the form of y equals mx plus c. So this is slope-intercept form, and the m refers to the gradient. So the coefficient in front of the x here, that's m. So for part A, m equals 3 over 2. Now part B, it's asking for the y-intercept, and remember the y-intercept is the constant, and over here our constant is positive 6. So what I can write is the C equals, oh, that's a bit of a funky blue, this was the one, C equals 6, therefore the y-intercept is equal to 0 and 6. Remembering that 0 corresponds to the x-coordinate, 0 corresponds to the x-coordinate, if I can get my pen size right, here we go, the x, and the 6 corresponds to the y. Now, part B, determine whether the following points lie on the line. Now, there's two ways we could do this. We could jump ahead and do C and graph the line and then try and plot these points on the graph and see if they line up with the line, or we can do it algebraically. So this question here, what it's wanting you is to do it algebraically, hence the reason it's been asked before graphing the line. Now, the way in which we can do that is actually quite simple. So dropping down B, and it's asking you, does point negative 2 and 3 lie on the line? So A, two and 3, was that a negative? Yeah, it was a negative 2 and a 3. And recalling our equation was y equals this guy. I'll put that there. Now, the way in which we can check whether this point lies on the line is if we substitute the value of x as negative 2 into the x here, and then evaluate the expression. If this point lies on this line, then the result should be 3. So I'm going to say y equals 3 over 2x plus 6. Then I'm going to say let x equal negative 2. So that guy there. Then back. So y equals, substituting the negative 2 in for the x, 3 over 2 times negative 2 plus the 6. 3 times negative 2 is negative 6 divided by 2 plus 6. 6 divided by 2 is 3, so it becomes negative 3 plus 6. Negative 3 plus 6 is 3. Thus y equals 3. Therefore, point negative to 3 lies on y equals 3 over 2 x plus 6. So this point does indeed lie on this particular line. So recall what we did was we wrote out the equation, then we said let x equal this x coordinate here, and then we compared to check that the final value for y, so evaluating the expression here, we got the value of y, and we checked whether it was equal here. It was equal, so we see that point negative 2, 3 lies on the line y equals 3 over 2 x plus 6. Now the next one we want to check is this one, 1 and 7.5. So let's dump it down here, 1 and 7.5, and we'll grab the equation. Then to be explicit, I'll write b. Here we go, b. And we'll ask ourselves, y equals 3 over 2x plus 6. And we'll say, let x equal 1. Subbing in the value of 1 for x, y equals 3 over 2, 1 plus 6. Then 3 times 1 is 1, so it's simply 3 over 2 plus 6. And then we have to do fractional addition. So 3 divided by 2, that's going to be a decimal. So I'll change this one here into a fraction, and we'll go 3 over 2. Then we'll go 6 times 2 divided by 2. This will become 3 over 2 plus 12 over 2. 3 plus 12 is 15 divided by 2. Thus, y equals 15 divided by 2 is 7.5. So, going back, when x equals 1, so x equals 1, y equals 7.5. Therefore, point 1, 7.5 lies on line y equals 3 over 2x plus 6. Now the final one, negative 6 and 2. So I'll put this down here, arranging it like before. Grab this one and put this one here. Then I'll make sure I clearly label what question I'm doing. So this is C. A little bit messy, I'll format that just a bit better. Alright, it's not going to let me do it. So that's what we're stuck with. So I'll follow the same process. So I'll rewrite out the equation, y equals 3 over 2x plus 6. Then I'm going to say let x equal the x value here, which is negative 6. Putting it all back together, 3 over 2 multiplied by negative 6 plus 6. 3 times negative 6 is going to be 18. So negative 18 over 2 plus 6. This will be negative 18 divided by 2 is negative 9 plus 6. And that will be negative 3. So we've got a different answer. So when x is let to equal negative 6, the value of y is negative 3. Notice that negative 3 is not present here, it is 2. Therefore, point negative 6 and 2 does not lie on the line y equals 3 over 2x plus 6. So going back, this one lied on the line, this one did not. Now finally it's got draw the graph of line showing A and B. So we have to plot, or in A it's asking us to plot simply the line here. Now we know that the constant is positive 6. So I'll go down and we'll say positive 6 is here. And it's asking for a gradient of 3 over 2. So looking at this, for every 3 we go up, we have to go across 2. So we'll go up 1, 1, 2, 3, and then across 2. Marking that on the graph. And then I'm going to draw a line going through these points, stretching to positive infinity and negative infinity. Now, as you would believe, I've already gone and done that. Now, the second point is we have to mark these points on the graph, and we'll see visually whether they actually lie on this line. So negative 2 and 3. Those points are, I'll mark that in a nice, let's go green pen. We'll make it nice and thick. So negative 2 and 3, going to negative 2 on the x-axis is here, and then up to 3. So right there. And that is negative 2 and 3. Next one is we have to mark 1 and 7.5. So going to 1 is here, up to 7.5 is roughly there. So as we can see, 1 and 7.5. And then finally we'll see the point that doesn't lie on the line. So negative 6 and 2. So going across to negative 6, we're here down to positive 2. Or up to positive 2. Notice that this point is indeed not on the line. So we can see it both algebraically and now we've proven visually that points A and B over here, they lie on the line here and here, but this C, point C, negative 6 and 2, it is over here and therefore does not lie on the line. So this is how we will do all of the calculations involved in question like question 3 here, noticing that we've done it with a different equation and some different points. So now it's your turn to have a go at question 3 here. If you have any troubles, let me know and we can go through it together.